Hello students, I Neha Yadav, Assistant Professor in ABES Engineering College, Ghaziabad. Today I am going to teach the fourth topic of Unit 4 of Discrete Structure and Theory of Logic. The topic is Order of a Group, Order of an Element in a Group, and Cyclic Group. So what is the order of a group? Order of a group is the number of elements in a group. As we have discussed in previous lecture, a group is a set which is equipped with the binary operator if this structure satisfies four properties which are closure, associative, identity element, existence of identity element, and the last property is existence of inverse element. Then this structure is known as group. So the order of a group is the number of element in this set. This is a set and this is a binary operator. For example, if we consider a group 1 minus 1, this example is also discussed in last lectures. If we take the operator as the multiplication operator, so this operator, consider this operator as multiplication operator. If we consider a multiplication operator with this set, then the order of this group will be the number of element in this group. So here the order of this particular group is 4. We also know that there exists some infinite groups. Here the set is infinite. So the order of this group is, order of this particular group is, if this is G1, then order of G1 is infinite. So if the order of a group is infinite, then we will call that group as infinite group. And if we have a finite group, then the order of the group is the number of element in the set of that particular group. Order of an element in a group. So the first topic was order of a group. So we know how to calculate order of the group. Order of the group is simple, the number of element in the set of that particular group. Now we have to calculate the order of an element in a group. So the definition says that the order of an element, if there is a element A in that particular group, then the order of that particular element A in the group is the smallest positive integer n, such that if we raise a to the power of n, we will get a identity element. So this n is known as order of this particular element A of the group. Here is the example. Here I will show how to find the order of an element in a group. Here these are the omega, the complex number omega and omega square, complex number omega. So we know that omega cube is -1. Now we have to find the order of each of these three elements in this particular group. Here the operation given is multiplication operation. So G is a group where the set is 1 omega, omega square, and the operator is multiplication operator, or we can say that multiplication operator, or we can also denote it by particular dot. So here we have to find the order of 1, then omega, and then omega square. The definition of order of an element says that if we are going to find the order of 1 or order of any element in a set, we have to raise that element to the power n, so that we will get identity element. And here we know that in case of multiplication, as the operation given is multiplication, we know that for multiplication, the identity element is always 1. The calculation of identity element is explained in detail in the previous lecture of this unit. So here we can say that the value of n, the smallest positive value of n will be 1. So order of 1 is 1. To calculate the order of omega, so omega, what power of omega will give you identity element? We know that omega cube is not -1, sorry, it is 1. Omega cube is 1. So here n will be 3. So order of omega will be order of omega will be 3. So next is omega square. What power of omega square will give you 1? We know that omega cube is omega cube is 1. So if we take the power 3 of omega square, we will get omega की power 6. Omega power 6 is omega cube square. Omega cube is 1, so 1 का square is 1. So here order of omega square is also 3. So here the order of 1 is 1, order of omega is 3, order of omega square is 3. So this is the way we can calculate order of each element of a group. Next question is find the order of every element of multiplicative group. The set is given and the operation is multiplication. So here the group is a set which consists of 1, minus 1, I, minus I. This is the set and the operation given is multiplication. So here we have to calculate the order of each of these 4 elements. So order of 1 is 1 to the power n, which will give us identity element. Here is also the operation is multiplication. So identity element for multiplication is 1. So order of 1 here is 1. Now calculate the order of minus 1. What power of minus 1 will give you 1? We know that it is always 2. Square of minus 1 will give us. So order of minus 1 is 2. What power of I will give us 1? We know that I is a complex number. We know value of I square is minus. We know value of I square is minus 1. So what power of I will give us 1? It will obviously be n is equal to 4. If we take I ki power 4, then I square, we can say that I square ki power, we can split 4 into 2. So I square is minus 1, minus 1 ki power square is, will give us identity element. So order of I is 4. Now we have to calculate order of minus I. So what power of minus I will give me 1? So if we raise minus I to the power 4, minus I to the power 4, it will give us I to the power 4. We can again split 4 into 2 into 2. So it will give us minus 1 ki power 2. It will give us 1. So order of minus I is also 4. So order of, if we summarize this question, order of 1 is 1. Order of minus 1 is 2. Order of I is 4. Order of minus I is also 4. This is the answer for this question. This is how we will calculate order of an element in a group. Next is cyclic group. So what is a cyclic group? A group G is called a cyclic group if for some A belongs to G, every element of G is of the form A to the power n, where n is some integer. For example, if we consider the previous example only, which is, for example, if we have A, B, C, and D as the element of the set, and here we have some operator, binary operator. So a group will be a cyclic group if we get an element such that if we raise A to some power n, we will get B, A to the power something m, we will get C, A to the power P, we will get D. If we generate all the remaining element by raising one particular element to some power, then that element will be known as generator of that particular group. And if we get one or more than one generator in particular set, then we will call that particular group is known as cyclic group. For example, if we consider this group, the set here is 1, minus 1, I, and minus I. And the operation here is multiplication operation. So here we have to find that whether it is a cyclic group or not. For finding whether it is a cyclic group or not, we have to check whether there is any generator in this particular set or not. So we will check one by one from 1. This is the element. Can we raise 1 to some power so that I can get -1? 1 to the power something, can I get -1? No, it fails here only. I can't generate -1 from 1. So I will not check for all remaining 2 elements. If it is a generator, it should generate remaining 3 element, -1, I and -I. It is not generating -1, so I can reject 1. Now I will consider -1. Can I raise -1 to some power so that I get 1? Yes, I know that n is equal to 2. -1 will give us 1. Can I generate -1 to some power? Can I generate I from -1 to power n? We can't. It is impossible to generate I from -1. And it is also impossible to generate -I from -1. So -1 cannot be a generator of this group. Now I can take I. Can I generate, sorry, can I generate 1 from I? We know that I square is -1. So if we take n is equal to 4, we will get 1. So at n is equal to 4, I can generate 1 from I. Can I generate -1 from I? I to the power something. Can I get -1? Yes, we know that I square is -1. So I can also generate -1 from I. Can I generate -I from I? Yes, we know that I square is -1. And if we take n as 3, we will get -I. So I am generating, here is the I element. From I am generating 1, -1 and -I. So from I can generate remaining element of the set. So this is called the generator of this set. I can generate all the remaining element of this set from this particular element. So I get the one generator for this set. There can be multiple generators for a particular set. This is the first generator. I will also check for -I. Can I generate 1 from -I? -I to the power 2 will give us -1. -I to the power 4 will give us 1. Can I generate -1 from -I? यहाँ पे n is equal to 4. Can I generate -1 from -I? n is equal to 2. Yes, -I to the power 2. So it will give us I square. It will be -1. So we can generate -I. Can I generate I from -I? Can I generate I from -I? It can be, let us check for 3. -I into -I into -I. So these two negative will become positive. This will become I square, and here it is I. So I square is -1. -1 into -I will give us I. So for cube, I can also generate I. So here -I is also the generator, as we can generate 1 -1 and I from -I also. So for this particular group, we are getting 2 generators. So this is a cyclic group, as a group with one or more than one generator is cyclic group. In this group, we are getting 2 generators. So this group is a cyclic group. Here is one more example for cyclic group. In this question, I have to show that 1 and 5 are generator of the cyclic group G. Here the operation is, this is addition modulo 6. It should be like this, addition suffix 6, not like this. So it is addition modulo 6. This operator is explained in the previous lecture of this unit. So I have to show that 1 and 5 are generator. It means that I have to show that 1 will generate 0, 1 will generate 2, 1 will generate 3, 1 will generate 4, 1 will generate 5. And I have to show same for 5 as well. So I will start from 1. 1 to the power 1 is 1. Okay. 1 to the power 2, here the operator is addition modulo 6. So the 1 to the power 2 is Here 1 plus 1. When we divide 2 with 6, we will get remainder as 2. 1 to the power 2. 1 to the power 3 will give us 3. 1 to the power 4 will give us 4. 1 to the power 5 will give us 5. 1 to the power 6. So here the sum is 6. We will get remainder as 0. So from 1 I have generated 0, 2, 3, 4, 5. So here 1 is the generator. Similarly, I can generate from 5. 5 to the power 1 is 5. 5 to the power 2. 5 to the power 2 doesn't mean multiplication. It doesn't mean this. Here it means power means we have to apply the operation the operation given in the group. So 5 to the power 2 means 5 addition modulo 6, 5. So it is the sum is 10, and when we divide 10 with 6 we will get 4. And then similarly 5 to the power 3 will be 9. Here this is 15, and when we divide 15 with 6 we will get 3. 5 to the power 4, here it is 20, and when we divide 20 with 6 we will get 2. 5 to the power 5. Here when we divide this with, when we calculate this, we will get 1. So using, and the last one is calculate 5 to the power 6. It will be, the sum will be 30, and we will get 0 as the output. 0. So using 5 also we can generate other remaining elements 0, 1, 2, 3, 4. So 1 and 5 are generators of this group. Hence this is a cyclic group. This is the reference textbook for discrete structure and theory of logic. Thank you for patience listening.